in anything that isn't there, make notes by it if you need to. Density is mass divided by volume. Mass is usually expressed in grams because we have gram balances in here. That's what we're going to measure with. Sometimes you'll see it in kilograms for the larger, more massive things. Volume, you'll see variations, can be centimeters cubed, which is also known as cc's or cubic centimeters. Milliliters, 1 milliliter is the same thing as 1 cubic centimeter anyways, or liters, depending on. We call this a derived unit. It's a derived unit because it has 2 units in the unit. So it's going to be a mass 1 over a volume 1. And I'm sure you've heard of like miles per hour. That would also be a derived unit. Or meters per second. Also another derived unit. Okay? So we'll be playing around with that unit. You need to make sure you're writing down the correct units as you're solving the problems. Now, density is the amount of matter per unit volume, and it's a ratio. Volume stays the same, the mass increases, so the numerator is going to increase, therefore your overall number would increase and your density would increase. If the mass stays the same but the volume increases, then your denominator is increasing, the bottom of the fraction, and your density will decrease. Now we use the handy dandy triangle chart. It is, solving for variables just like you would in algebra. The overall equation is this one. However, if you do the DMV triangle, like so, this line right here is going to represent a division. This line right here is going to represent a multiplication. I'm not sure if you can see that in the way the diagram is. So any of the missing variables, you can figure out what to do. So say you're solving for mass. Okay, you don't have mass. So you look here, it'd be density times volume. And that's where you would get this one, that equation. Okay? Now if you didn't have say you were missing the volume, then you would take the mass and divide it by the density. That's how the triangle works. You can always write this on your paper for the quiz or the test if you're doing your scratch paper. Last but not least, if you're solving for density, mass divided by volume, once again, using the nice little variable triangle to help you figure out how to isolate which one you're missing, just like you would in algebra. What would take up more space, a kilogram of feathers or a kilogram of steel? Feathers are more spread out, right? They're taking up more space.
Oh, yeah, right.
One takes up more space than the other. And so in this case, it is not just about how heavy it is, how massive it is. Why is it going backwards? I'm pressing the wrong one, sorry. Okay, there we go. How close they are packed together. So you need to also be considering the space that it's taking up. It's about the compactness. So, looking here, you have your particles. They're more spread out, like these over here. And then they're put in a nice orderly fashion. This one would have a higher density down here. And we'll also be specifically talking about the different densities of our phases. Like gases. We know gases fill their containers completely. And they have lots of kinetic energy because they're moving around pretty fast. So the greater the kinetic energy, the more it's going to spread out. So it's going to take up more space. You take up more space, you're going to have a lower density. So as on your sheet there, it shows you that gases densities are usually going to be the least dense, or the least dense out of all the phases. Now, cold air compared to warm air, temperature plays a factor here. Cold air, the particles of the air are closer together because they slow down and they're not moving as fast. Warm air, they're more spread out. So if you're looking at from a weather perspective, and a low pressure system, which is got very good warm air, kind of like the hurricanes we're producing, that has a tendency to rise. The cold air, though, has a tendency to sink. That's just because the molecules get closer together, therefore they're more compact, therefore they're more dense, going to sink. Liquids, you dissolve more things in a solution, the more dense you're going to get. So salt water is definitely way more dense than just regular pure water. Cold water also, they get a little bit more compact and has a tendency to sink in warmer water. And if you've ever been in a lake where it hasn't been mixed up in a while, the top layer is real warm, but get down further, it gets real cold. They pack in more. But the basic gist of what we're talking about here is the fact that it's going to layer out based on density. So this layer right here is the least dense out of the three. It's on top. The middle layer is more dense than the top layer, but it's less dense than the bottom one. This one would be the most dense out of all three. So you'll see them layer out based on their densities. More will sink, more dense it is, less dense it will, be on top. So if we had mercury and lead, based off of their density values right here, kilograms per meter cube, what would you say? What would happen? Is the lead going to sink in the mercury liquid, or is the lead going to float on top of the mercury liquid?
The lead is going to float on top of the mercury liquid.
That would be correct, because the mercury is our only liquid metal, is more dense based off of those values, and you'd see the lead in the 3 ball here. Okay, sitting on top of the silvery liquid. And lead's pretty dense. Very, very dense. Okay. Solids are typically more dense than their liquid form. However, we have this one variation, and that happens to do with ice. We all know that that's a special property of water where ice is less dense than its liquid counterpart. That makes the ice float, which is nice for the organisms that have to live in the water during the wintertime, because then the ice will freeze on top, but underneath they still have an ecosystem to live in. Because if not, if it froze from the bottom up and was more dense, their ecosystem would get smaller in the wintertime. And if it completely froze, then they wouldn't have one. So it freezes on top, and they still have the water underneath to live in. Okay. Various rocks, woods, metals, they all have their own specific density. So it's very characteristic of the particular substance. And like for instance over here, everybody know what this substance is?
Gold.
Gold. Gold is one of the most densest substances out there. Wouldn't you like to have a bunch of that? Sure, we'd all like to have a bunch of gold. However, this is what's kind of funny. If you're looking here, there's a few, the bars are trying to represent here's gold right here, how dense they are. So, iridium is very dense, osmium is very dense, gold is very dense, and they try to portray that, thieves would want to go to Fort Knox and steal the gold, or go to a bank and steal a bunch of gold. But just one suitcase full of gold is going to be about a ton. And that's not very easy to carry. And just 1 cubic foot of gold, 1 cubic foot. So that's 12 inches by 12 inches by 12 inches. That is going to be about 1,200 pounds. So it's very heavy stuff. Not easy just to, take out of the bank there. Now, you're going to get density charts like this, where it's going to give you a bunch of densities. You need to be able to tell whether it's going to float or sink in comparison to, say, this one is the comparison of water. So if we're looking at this value for water, which is 1 gram per milliliter, the things that are going to float are going to have a density that's less than 1. The ones that are going to sink are going to have a density more than 1. So 11.3 is definitely more than 1. That's why the lead would sink in the water. However, ice, 0.93, is less than 1. So that's why this one's going to float. So everybody get the concept? Because this is kind of a question they like to ask, and this is one that you would need to know for the test. Definitely. Question? So be able to tell based on the densities whether or not it's going to float or sink. Now for the problems, which you're going to be working some tonight and tomorrow night for Friday stamping. What is the mass of the metal with a density of 11.30 grams per milliliter and a volume of 25 milliliters? Yes. But let's set that up. So if we do our little chart here, we are missing the mass. This is the one we're missing. So we're going to do density times volume. You're semi-correct too, because we forgot to round to the correct number of significant figures, because all calculations now need to be rounded to the correct number of significant figures. For all the rest of this year, and maybe also in physics, because I believe they also use significant figures. So, density, here it is, 11.30 grams per milliliter. We're going to be multiplying that times the volume, which is 25.0 milliliters. That's going to give us our mass. What you also need to be aware of, since milliliters is on the top here, milliliters on the bottom, they're going to cancel. You're going to end up with grams. Well, that's good because we're solving for a mass. You need to be able to cancel those units and make sure you're getting the right unit. And what was that value again? 282.5 is the calculator answer. Now, if you look at our measurements, the first measurement here has how many digits? Good. Starting from the left, that's going to have 4. How about this one? Starting from the left, decimal point, 3. So my answer can only have 3. So 2, 8, and this is the one we're going to round this to. Is it going to go up to a 3 or stay at 2?
Stay at 2. 3.
Is this 5 or above?
Oh, wait.
It's going to go up. So 283 grams. That would be your final answer. Don't forget your unit. Units are important. They must be on there as well. Yes?
Does it have to be grams per milliliter or just grams?
Well, we're solving for a mass, so it's going to end up being grams because the milliliters will cancel.
Okay.
But the density measurement will have to be a derived unit. You need a mass measurement over a volume measurement to get the density. Yes? So that would be setting up problem 1. Let's look at problem 2. Different variable missing this time. What is the density of a gas whose volume is 3.4000 times 10 to the third milliliters and has a mass of 1.45 grams? So we're missing the density this time. Very good. We're going to set up our little triangle. So this case, we're missing the density. That means this time I'm taking the mass and dividing it by the volume. And now I look up here to plug in my numbers. The mass, 1.45 grams, divided by the volume, 3.4000 times 10 to the third milliliters. So in this case, none of the units can cancel, so that's why both of them are going to stick around and become the derived unit. Punching this in the calculator, because it has the scientific notation, you can use the exponent key, which is second, and then the double E on the graphings, or your exponent key on the ones in the classroom are next to the equal sign down below. It says EXP next to it. And all you would do, you type in your 1.45, hit divide, and then type in 3.4000, hit your exponent key, the 2 zeros pop up, and type in a 3. That's what you would do there. If you're using the graphing, then you would do second and then the comma button, which is right above the 7, and that will give you the exponent, and you would type in a 3 after that. So we get a very small number, which makes sense because 3.4 times 10 to the third is like 3,400. 1, 2, 3. So it's like dividing 1.54 by 3,400. So you should get a very small value. Now we have to look at our significant figures. How many does this one have?
3.
How many does this one have?
5.
5. So how many do we go with?
3.
3. We keep the 4, keep the 2. What do we do to the 6?
Yeah.
Round. But do we round it up or leave it a 6?
Leave it a 6.
Leave it a 6. Good. Don't forget your unit. This time it's grams per milliliter. You need both because this is the density. It needs both units. It's that ratio of the mass over the volume. So our last problem, what do you think is going to be the missing variable this time? Volume. That's the only one we haven't done yet. So we're going to do the volume one. So we're missing volume. That means we need to take the mass and divide it by the density. Okay? Now we can plug in the numbers into their respective mass and densities here. So we have 10.6 grams being divided by 0.55 grams per milliliter. And you see the grams over the grams here are going to cancel. So we're going to be left with milliliters, which is a volume unit, which we want anyways. So let's get our calculator answer.
19.27.
So I get 19.272. Let's look at our numbers here. How many does this one have?
3.
3. How many does this one have?
2.
Only 2. So how many do I keep?
2.
So look to my 1. Don't round that. But the 9, do you round it up or leave it at 9?
Leave it a 9.
So this is going to be 19 milliliters. Final answer. Sig answer. Not too difficult, right? Use the triangle. It's helpful. Now let's talk about a few little extra aspects before we get into the lab for tomorrow. You're going to be using this method. It's called water displacement. So we're going to use the displacement of the liquid. This is on your sheet, but it's showing you kind of a different example there. You're going to put some water in a graduated cylinder, and you're going to find the measurement. You're going to write that down. Because we're going to be using irregular solids. They're going to be like pellets. So they're not going to be something you can measure the length times the width times the height and do the volume that way. Then you're going to drop them in to the graduated cylinder gently because we don't want to crack the graduated cylinders. And the water should do what? Rise. So it'll rise up to a measurement. And you'll take your final volume. And then you'll subtract them. You have your starting volume, you'll subtract your take your final volume, subtract your starting volume, and you'll get the difference will be the volume of the irregular solid. So you're going to do that technique tomorrow. And that's also on the note sheet there, so follow that. A couple other quick things that realizing that density is affected by temperature. Temperature makes them move faster, so they spread out a little bit more, so usually they're less dense if there's a higher temperature. Also pressure, being put under lots of pressure makes it be more compact. So pressure and temperature do affect the densities of substances. Keep that in mind. Another factor affecting the density is whether or not you dissolve something in the solution and make a mixture. If you do, you're packing in more particles, so the density obviously would change. Pure water is not the same as salt water. Definitely have more particles in the salt water than in the pure water. So the density would be more than just regular pure water. last but not least, we're going to be doing this with our data from the lab. We're going to be graphing our density. Each group is going to have a different amount of the sample to do, so we're going to plot the lines. We're going to have the class data to be able to plot the graph. What you should see here, mass is going to be on the y, and volume is on the x. So if you have your mass and volume, you can figure out the density at any point on the line. Another good thing to look at is the slope of the line to tell you relatively how dense it is. Something with a very steep slope over here, like the gold, look how steep that is. Gold has a very high density. We already talked about that with the cubic foot is like 1,200 pounds. Very dense. Whereas something like aluminum, the dashed line here, it's less dense than the gold, but it is more dense than, say, the gasoline over here. Gasoline has a more shallow slope, so it's less dense than the things that have a more steeper slope. So we will be looking at the density graphs and graphing our data from the lab and doing some calculations from that.